Hey guys, let us start with solving question number 5. That is, find nth derivative of y is equal to ax plus b raised to the minus m, where m is a positive integer. M is a positive integer. If we differentiate this y, then we will get y1, that is minus m into ax plus b raised to the minus m minus 1. This is because we know the formula of derivative, that is derivative of x raised to the n is equal to n into x raised to the n minus 1. By using this formula, we can write first derivative of y as minus m into ax plus b raised to the minus m minus 1. So if we differentiate this function again, then we will get minus m minus 1 a into a square ax plus b raised to the minus m minus 2. Again we have used the same formula. Here our observation is, here is in first derivative there is only one minus sign, in second derivative there are two minus signs. So we can write this as minus 1 square into a square into ax plus b raised to the minus of m plus 2 into this is m into m plus 1. If we differentiate this again, then we will get y3, that is minus m minus 1 minus m minus 2. We are writing this is from this step, that is y2, into a cube ax plus b raised to the minus m minus 3. Again we have used the same formula, this formula. So here are three minus signs, so we can write this as minus 1 raised to the power 3. This can be written as m into m plus 1 into m plus 2 into a cube into ax plus b raised to the minus of m plus 3. So by observing its pattern, we can generalize this up to nth derivative. What is our observation? In first derivative here is only one minus sign. In second derivative here two minus signs there, that's why we have written this as minus 1 to the power 2. In y3 here are three minus signs, so we have written this as minus 1 to the power 3. Here power of a is 2, here power of a is 3. Similarly, see this minus of m plus 3 minus m plus 2. And most important observation is this: in first derivative there is only one term, that is minus m, or we can say m. In second derivative there is one extra term, that is m into m plus 1. In third derivative there are three terms, m into m plus 1, m plus 2. That is, if we are taking nth derivative, then we will get m into m plus 1 dash 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 up to m plus n minus 1. So by observing this pattern, we can write our nth derivative as minus 1 raised to the n a raised to the n into m plus 1 into dash 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 into m plus n minus 1 into ax plus b raised to the minus of m plus n. So here all terms are terms are starting from m up to m plus n minus 1. If we multiply this term with m minus 1 factorial in numerator and denominator, that is, as our yn is minus 1 raised to the n m into m plus 1 dash 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 into m plus n minus 1 into a raised to the n into ax plus b raised to the minus of m plus n. Here terms are starting from m. So if we multiply this term with m minus 1 factorial, then numerator get converted into m plus n minus 1 factorial. As we are multiplying this here, we have to write the same term in denominator. So we can write this as minus 1 raised to the n m plus n minus 1 factorial into a raised to the n upon m minus 1 factorial into ax plus b raised to the minus of m plus n. So this can be written as minus 1 raised to the n m plus n minus 1 factorial into a raised to the n into a into upon m minus 1 factorial into ax plus b raised to the m plus n. This is by using rules of indices.